Hello, my name is George C. Bradley, and today's presentation will be on how to run a one-way analysis of variance using SPSS. For a one-way analysis of variance, each individual or case must have scores on two variables, a factor and a dependent variable. The factor divides individuals into two or more groups or level, whereas the dependent variable must be at the level of interval or ratio. Let's look at our data set. The name of our data set is supermarket.sav, and the factor is shelf, or the independent variable is shelf, and the groups are labeled 1 equals shelf 1, 2 equals shelf 2, 3 equals shelf 3. Sales, that is the dependent variable, the amount sold from on each shelf, the amount sold on each shelf, and this is free online. Be mindful, what we're trying to find here is there a significant difference in the amount sold on each shelf. Let's take a look at our data set here. The dependent variable sales, you can see we have 38 and shelf. This is our factor, our independent variable. And let's analyze this information. Let's go to compare means and down to one-way analysis of variance, or ANOVA. We can see here in our dialog box dependent list, we can put our dependent variable there, and that's sales, and you can see we have room for several, but we're only using one. And we can highlight shelf, and we can go and put that in our factor. We don't need anything here. We can go to post hoc, and we'll use the Tukey test. And the Tukey post hoc test is a popular test that's used in ANOVA. As you can see, we'll go to options. So we have several options here. Let's look at descriptive. Let's look at homogeneity of variance test, and that would be one of our assumptions. Let's also plot the means and get a visual representation of the amount sold, the average amount sold on each shelf. Nothing in bootstrapping. I think we have everything that we need here. Let's analyze the information. As you can see with the descriptive statistics, what we have here, with shelf 1 we have 14, and the mean is 13.57, and shelf 2, 12, 17, 17.67, and shelf 3 we have the number 12, and we have 25.5, and that's our descriptive information. There's more, but those are the means of each shelf. If we go here to the test of homogeneity of variances, we can see that's the Levine's test, and the important thing here is the significant level. The significant level is 0.148, and that is greater than 0.05. And if it's greater than 0.05, we're saying that the variances in each one of the shelves, the group, the spread here, are the same. We can go here to the ANOVA table, and the ANOVA table, and with the ANOVA table, we have a significant level that's 0.000, and that's less than 0.05, which is our alpha, mostly in the social sciences, our alpha level. And that means there is a difference between the shelves. There is a difference. And we can go down to our post hoc test, our multi-comparison. The star in the means different column indicates which pairwise comparisons are significant. And as you can see, you have a star in all 6. So all of the different combinations are significant there. 1, 2, 2, 1, 3, and you can see they all are significant. With the 1 and 2, that's a 0.035. Okay, so they are different. Let's look at a pictorial representation here in the mean plot, and you can see in shelf 1 is the lowest, shelf 2 is the second to the largest, and shelf 3 has the most sales going on. And you can see the difference here in this plot. Are there any questions? If you have any questions, please email me at georgecbradley59@gmail.com. Thank you very much.